Always looking to make more friends, especially you smart Johns Hopkins students. If you see anybody that I'm connected to that you want to reach out to, by all means, I will send you through. Probably more important on this page is your TA. Actually, your TA is not Mohammed, it's actually Andrew Park, but you could probably contact Mohammed. He'll answer some questions for you. I run a company called SoCat, named after my two daughters, Sophie and Catherine, and that's all we do is AI and machine learning, and we do government contracting. So we do it for different agencies and a few select startups. But that's, where I come from. Prior to doing, I've been teaching for about 12 years, 13 years at Johns Hopkins. And this class, AI Essentials for Business, used to be called Big Data Machine Learning, which is the course that I created. So, I think that I'm trying to keep this course useful for all students that take it, right? And give you guys some skills and tools that you can use like tomorrow, right? Okay. So today we're just doing the course intro and the overview of AI. Next week we're going to do employee neural networks. Next week I'm not going to be here on the Friday, but I'll make a video and post it up here probably on Thursday. That's why I'm trying this video format, because I want to see if this is better than a Zoom link. I'm just trying to figure out what is the best way to provide this to you. And then we'll move on. I may adjust things because I think I'm going to move the generative AI and the AI agents a little bit further up, because I think that's really important. And so just be flexible here, because, but by and large, I think you'll get most of this materials more from a finance point of view, a Wall Street point of view. So for those who, feel free to give me feedback as well. Okay. How are your grades going to be computed? This is what all students are curious to know. It's a very simple formula. Class participation, coming to class, adding value is 10%. Your weekly assignments will be 60%. And then the final presentation will be the remaining 30%. So you'll be tasked to create a presentation. You can do it in groups of 1 to 3. And then you guys will present and make it like a 5-minute video. And then the last class we'll watch and we'll review, and you guys can answer questions, okay? And what are you going to do? You have to solve a business problem that is important to you. You can bring in your data, whatever it is. The only thing you have to submit for the final presentation is your 5-minute video and then your code. And if you use any PowerPoint materials, then that too. Okay, so that will be it, and then that'll be the end of this course. It goes by very fast, and week 8 is really these are 8-week courses, so they're done. They're over pretty quickly. Okay. Your WOW presentation, be creative and very clear. I think that's the advantages of going to business school. You practice to be clear. You have to solve a business problem, like a real world business problem. So you have to articulate what is the problem, what is your solution, how are you using AI to solve this. You don't have to just use the techniques that you learn in this class. You can use any techniques that you want, whether it's in this class, over your lifetime. Feel free to bring in your data. I'm not going to ask for that data whenever you present. You can keep your data to yourself. If it's proprietary, that's fine. I don't want your data. I just want to see how you thought about the business problem. I want to see your video and also your code. I don't need the data. And more likely than not, your code is just going to be generated all from kind of like windsurf, right? That application. But I want to make sure that you did it, right? Okay, and I encourage you guys to stretch yourself and try to learn something new or apply some new techniques. But you need to be able to articulate it and explain it in a way that people can understand, okay? It cannot be sort of like this thing that you don't, you're going to have to share some intuition and some lessons learned. All right, so here's the brief history of AI. I'll talk about the winter. This is a very nice map. This is from NVIDIA. I've extended it. So from the 1940s and 50s, we know everything is artificial intelligence, right? It's all artificial intelligence. In the period from 1980s to 1990s, this is where the internet comes in and provides a lot of data. Is this email spam or not spam? So that's machine learning, right? Supervised machine learning. And then deep learning has to do with this is where Feifei sort of created that ImageNet database, and basically you were looking at different pictures, and this is where the other schools were competing to find out what is the best performance in order to identify images in a picture. From there, we moved on to sort of generative AI and large language models. A large language model is any model that has billions or more parameters, okay? The moment that really put us on the map was this ChatGPT. That's November 2022. That's not very long ago, right? DeepSeek came out actually February of this year. And I'm going to show you my Neo moment. Hopefully this will work, but we'll see. Tell me if this you can hear anything. Are you guys ready? Turn up your speaker. If this works, it'll be cool, but if it doesn't work, that's okay too. Are you ready? Okay, listen up. I'm going to interview this robot called Neo.
What's your name? Neo.
Yeah, nice to meet you.
Nice to meet you.
Do a peace sign. Neo, do a peace sign. Peace. 안녕하세요.
Come again.
안녕하세요.
안녕하세요.
We're gonna back up now, Liew. Are you ready to go charge?
Jump.
See you later.
Okay, so why is this my Neo moment? Okay, so I saw this robot at NVIDIA's GTC, and I went over there and I wanted to interact with this robot. And I wanted to think to myself, is this really a robot, or is this somebody who's sort of manning, the voice and looking out the camera's eyes? Is this a human being sort of sitting in the stands or whatever it is, right? Because that could happen, right? And so I went up to it and I kind of was interviewing it, right? I wanted to see what it could do. One of the things that was kind of surprising, when it didn't understand what I was saying, I was trying to make it see if it could understand Korean, 안녕하세요, right? It said, come again, but it said it so quickly. It's almost like I'm interacting with one of you guys and you didn't understand what I was saying. And you said, like, Professor, come again, right? And then the other thing is, it was pretty fluid. And when I left, I was like, that's pretty darn good. If that was all AI, that's really, really interesting. Now, obviously, they took Neo away because I was telling it to jump up and down, and, it's not quite there to do that. But the thing to think about now is that this is going to be the worst experience that we've ever had with AI robots. And Jensen Huang, he said that he thinks one of the largest industries that are going to come out of all of this AI has to do with robots and robotic workers and so forth. So I thought that was really, really interesting. And this just happened like last week. So this stuff is developing very rapidly. It's super exciting for those who are thinking about where should they position themselves for future jobs. I just don't think that this is a bad place to lean into, right? Anyhow, feel free to comment. What do you guys think? Should we watch it again? No, we won't watch it again. All right.
What's your name?
I think it's pretty remarkable. I was able to jump and kind of react to kind of different inputs, and it was so fluid. And you even see that latency in trying to make some of the AI agents and some of the voice models you can download in terms of how quickly they can interpret the information. So I was very impressed by it.
Yeah, I was shockingly impressed by it. But then after I left, I was like thinking to myself, wow, we have come a long ways. And I kept thinking to myself, no, that must have been a human there. They must be just, it's too good. I mean, it's surprisingly too good. The latency is like down to nothing, right? It's like a human being latency, and it's weird. I was like, wow, that's very impressive. Now, some people say that teaching is going to go by the wayside of AI. And probably in your lifetime, you're going to have like 5 different professors at your fingertips that know you inside and out and will continue to educate you, right? So some people were predicting that teaching for, like what we're doing here, where there's a professor and there's students, within 10 years, probably 5 years, we don't need it. You'll be able to, fire up 10 of your favorite professors, right? And then they'll be at your fingertips on your phone. So I think it's going to disrupt many, many industries. But it's interesting. Even though as technology, becomes deployed rapidly, what I've noticed also is that people still wanted to hang out. So at that conference, I hosted one of these, was it like a brain date? And I said, hey, I'm a professor at Johns Hopkins. I'm, putting together some AI essentials. And in my course materials, does anyone want to meet and share their experiences, and maybe we can share some lecture notes or whatever. And a lot of people sort of signed up, and it was fine. It was fun. I got to talk to people, and even they obviously were smart and they were on the cutting edge of this stuff, but they didn't know where it was going to go. So when technology hits an industry or market or whatever society, and we don't know where it's going to go, the people who are interacting with that technology are going to see where the puck is going to move, right? And that's what I'm hoping that you guys get a chance to do, right? Interact with the technology, think about where the opportunities are going to be from a business perspective, and then sort of share that, right? But you're not going to be able to see where things are moving on the frontier if you're not interacting with, actively. So I encourage you every day to, interact to the extent that you can, and see how that changes your workflow, in your professional life and so forth. Because it's also fun. It's interesting. Yeah, go ahead. Bobby.
Yeah, I mean, I don't have any doom or gloom type of outlook. I can see in 5 years the beginning of what I would call an AI concierge for every single person that would just start. So, and start from a young age. Like, you will actually have an AI that you'll grow old with, that will be your personal, the whole time you are living. Like, it whether it's on your watch, your phone, or a robot like this, it will be somebody who's with you at all times, that will be from everything from, accompanies you to every workout, to every movie, to everything. Like, make sure you do this. I got to remember that for my taxes. I got to do it. It will be what your phone, people don't remember what it was like when you didn't have a phone. There will be a time that you don't remember when you had your AI concierge.
That's right. People don't remember whenever you'd say, hey, I'll meet you by this lamppost at 7:00. And then you miscommunicated the lamppost and you're like, where are they? Where are these kids? Where are my parents? And then there'll be an hour wasted looking for people. Where are you? Right? Remember those times? I'll meet you by the car at 6:00. Okay, Dad. Okay, is this the right car? My kids are lost. Oh my gosh. Oh, all the good times before GPS, right? But yeah, no, I agree. I think we're going to have, AI assistants at our fingertips. Some of these tasks like, just think about what you don't want to do, right? Teaching is definitely going to go by the AI way. I think mid-office, back-office stuff, even sales is going by the AI way, hunting down leads and warm leads and so forth, right? Taking notes. I'm sure some of you guys have your AI there to summarize all the lecture notes, which is fine and great. You should definitely sort of talk about it and share it. But yeah, we're living in a very exciting time, and AI is not something that's hyped. It's like, it's at your fingertips right now. It's at everybody's fingertips. It's empowering everybody. So it's exciting. Linda, go ahead. You have your hand up?
Yeah. Bobby, yeah, that's a great idea. And one thing at my company, like was been talked about, is more an experience with concierge with an augmented reality, where you have like Mickey Mouse as a guide at Walt Disney World or on a cruise ship.
Where do you
and
work?
then it's very personalized. to you specifically.
That's amazing.
But that is the other thing, is like, what are the tools that are best used for like virtual reality and augmented reality? Because not everybody's going to want a robot following them around everywhere physically, or maybe just one robot, not a bunch of them. But it's interesting because I feel like it's rapidly happening. And how do we catch up? How does one person stay on pace with this technology?
That's great. Wait, which company do you work at?
I work for Walt Disney.
Oh, cool. Can you give us a couple of those Disney things, so that we can hang out and Disney?
Like tickets to the park?
No, I want that virtual thing. I want to see what the cutting edge that Disney's doing with this stuff.
Yeah, so there's a lot of things being worked on. These are all ideas that are thrown around. I work more on the TV and entertainment side, and how we have using experiences with VR and augmented reality, and how we use AI, and what are our different proof of concepts that are being experimented with, and how we get the most value out of it. But a lot of people throw out the ideas, and Bobby gave like that great example of a concierge, and I'm like, that's like the perfect one that Disney would love to see, is like a Mickey Mouse concierge that knows you and can show you around.
So, do you think Disney will ever be able to understand the user so well, and how the user's reacting to watching, sort of the movie or the TV show unfold? And, maybe that Disney will predict, okay, for Professor Liew and he's with his two daughters, let's do a happy ending in terms of, the something good has to happen out of all this stuff. Because I remember the princess stories, most of them were pretty happy, right? And when I was watching with my daughter, she got into that stage where she was a princess. But then the stories kind of stayed at the same level. They didn't get really, complex. And then at some particular point, she's like, right before she's going off to college, she's like watching Breaking Bad because she likes that, right? And so, I noticed the stories didn't change in Disney. Maybe they did it for a reason. But I'm curious, like, what's going to be that entertainment company that actually sort of personalizes your whatever show? Maybe it's Darth Vader who ends up being the good person, whatever it is, right? But you get feedback, emotional feedback from the end user, and now you have a movie specifically designed, or some kind of Disney show specifically designed for you and your family. Is that going to happen?
Yeah, there's a lot of talk. I don't know if anybody remembers these books years ago called Choose Your Own Adventure.
Yeah, I remember those. Yeah.
Right. And so there's been some interactive content, not just on Disney platforms, but on other platforms where you can kind of interact and play around. And there's just been a lot of experimentation that you might have seen coming and going. So you would need, to accept some sharing of your personal data. So there's a lot of privacy laws out there. And to be very clear, like, you need to accept and agree to terms as you move along, and then be able to have the technology that if you unaccept or take it away, that you should be able to do that as well, so that your data isn't stored personally. Although I would say the data that we have on customers out there, that's not just at Disney, but in the industry, is pretty creepy. It's the term. Yeah. It's the term. The amount that, like, they know if you have a dog at your house or a cat, or how many people live there, and how many people watch your streaming services. And if you set up profiles, it has an algorithm that bases what you historically watch and offers suggestions on what you might want to watch. It's not always perfect, because somehow my kids get into my account and I've got nothing but anime on there. But it's getting smarter all the time.
Yeah.
And I can't go down on any specific proof of concepts we're working on, but we're still years away from things, but then something can come out next week.
Exactly. Well, okay, that's fascinating. It's very fascinating. It's interesting that you're working at Disney, and Disney is sort of thinking about along these lines. Yusuf, do you have a question?
Oh, I just had a thought. I'm excited for AI as anybody else, but one thing I've been thinking about lately is, like, not the downside of AI, but how it'll adversely affect us as humans. For instance, I've recently, when I started driving, we didn't have navigation systems, but recently I've been so dependent on my car, like even around my own neighborhood, I have to look at the navigation system, like what street am I on if I take a wrong turn, which is kind of depressing to me because I pride myself on being able to self-navigate. But in that same, arena, if we're offloading, our thoughts, our functions and things that we do to I imagine we'll stop exercising those muscles, and it'll be interesting to see how humans evolve and lose skills as we're gaining abilities.
I think that's a good point. So as you guys are learning how to use Google LM, find out if you're becoming lazier because it's so easy to just dump any PDF in there, read the summary and listen to the podcast and say, I'm not interested. Or maybe I should read this more in depth. But throughout this course, please do share how AI and the tools that you're getting empowered with is changing your behavior. I think it's very interesting. It could be exciting, but you bring up a very good point. Okay, so I'm not going to cover all of the developments, but this is the trifecta that we discussed before: the hardware, the data, and the models and algorithms. And basically, the way to think about hardware is just think Jensen Huang and NVIDIA and all the NVIDIA's competitors. They have this thing called Blackwell, and he keeps innovating on the hardware side, which means that you're doing more with less in terms of computational speed and so forth. The tsunami of data is like the internet and our mobile phones and like every sensor out there, right? But the scary thing, as was mentioned by Linda, is that a lot of this data is being stored for a longer and longer period of time, right? Whereas, in the old days, we're human beings, we'd have memories, we'd forget things. Now in the digital world, it's like a digital fingerprint for a long, long, long time, probably until the corporation doesn't want it. One thing that's a little bit scary is, I don't know if anyone's used 23andMe, which is some kind of genetic sort of, you give it some blood or something like that. I had a friend who did that, but that's your genetic code. And now 23andMe is being bought by another company. So maybe you trust the initial founders, but what if this company is some company that you don't want them to have your data? I think there's a way to opt out, but how do you know that opting out is going to sort of be implemented correctly? And how do you know that, that their database, whoever buys 23andMe, doesn't get hacked? So, these are some considerations that are very important. Most people trust Johns Hopkins and they trust the data is safe in Johns Hopkins. What if Hopkins loses its funding and X, Y, Z happens? Those are the things to think about, right? So the tsunami of data, the hardware, and then the large language models, this is the algorithms, and the models only get better. Now, the scaling laws are basically taking these three sort of components and understanding that there's a predictability when you go down, it gets better and better and better. As you increase the compute power, the loss function gets stronger and stronger. That means the models get better and better. As you put in more data, you get better and better results. And as you add more parameters, and now we've sort of exhausted that, we know that about 100 billion to a trillion parameters catches quite a bit of these relationships in the historical data that we've sort of pushed in, right? Now there's a trend towards smaller models that are very specific in terms of what there are experts at. So for example, you may have an LLM that only knows finance, right? So you could argue you're inside this class and you're distilling. You guys are the smaller LLMs. I'm the big LLM. I'm distilling the knowledge to you. And that's how the classroom works, right? And if you want to learn marketing, you don't go to the finance class, you go to the marketing class, and the same thing works, right? There's some expert in marketing and she's or he or whatever it is distilling that information to you. If you want AI in healthcare, that's Gordon Gao, right? So you go to his class and you sort of get that information from him. Now, no human being can do it all. And we have our areas of expertise and we have our own styles of teaching, whatever that may be. But one thing to remember is it seems to be the case that we're organized very similarly, right? Meaning that there's experts and students will come and learn from that particular expert, right? So it's interesting how as we create these larger and larger LLM models, it sort of comes back to how human beings are sort of use their brains, right? And how they interact, professors and students, how the knowledge is transferred, what the student tries to do to gain more knowledge, and then ultimately you guys will disseminate your knowledge and get distilled by maybe your kids or other people along your career path. Maybe you will mentor and so forth. So it's fascinating, but at the same time, what these scaling laws were telling us is that it makes a lot of sense to add more compute power, to at some point add more data. We've exhausted the data historically, but going forward, we know there's going to be a lot more data that's going to be able to be sort of pulled off of these measuring devices like our cell phones, our wearables, and sensors, and so forth. Here's a slide which has to do with flops per dollars. I'm not an expert in hardware over time, so this is where Kashabi sort of knows this stuff. We sort of discussed this. The amount of data continues to grow exponentially. And then these are the algorithms. And you'll have a little bit of experience working with some of these algorithms like Atom. It's an optimization algorithm, right? And you'll see that sort of in practice, not in this class, probably next class. And these are the state of the art. These are over time, these years, 1950, 60, 70, 80, all the way to 2000. And these are, sort of 1 billion, 10 billion, 100 billion, trillion, and, all the big models, LLMs, these are the usual suspects, Google, Meta, and also OpenAI, right? All right, so basic tips. First, here we go. Use ChatGPT and Anthropic for most of the stuff. So if you want just the general sort of purpose, hey, what should I do? How does this work? These are pretty darn good. They'll give you pretty good ideas. Like if you say, hey, I didn't understand the perceptron. Can you give me a couple examples of the perceptron? I'm taking an AI Business Essentials class, right? If you want to know a little bit more about a certain topic that we're covering, usually what I do is I say, hey, could you explain this to me? And, could you provide some Python code? Now, I can read Python code. I'm not an expert coder, but I can sort of see how it works. The other thing, it's like, can you explain that to me step by step? Or can you explain that to me like I'm a fifth grader, right? So if there's a new concept that I really want to sort of drill into and remember or understand, I'll ask it to explain it to me a couple of different ways, right? That's how I kind of understand concepts. You may be different. You may be like, rap me a song so I don't forget, or, create a picture so I don't forget. Now, what I want to do here is take a little bit of a break, but before we take the break, can you guys see the HTTPS codium.com/windsurf/students? Guys, can you see that URL?
Yes.
Okay, I want you to, I'm going to copy this through. I'm going to stop this, pause it. So most of you guys can, are you guys there? Can someone say hello?
Hello?
Okay, perfect. Most of you guys could get your snake game working, or at least that's part of your homework assignment. Now, one thing to think about here is the snake game code is out there on the internet. It's probably using pieces of that code. That's why you can create it pretty well. Your assignment will also be not only create the snake game, but also create another game. And then you're going to take both of the games and try to merge them together and have the LLM or Windsurf create a new game that's never been seen before, that's a cross between the snake game and whatever game you want to add to it. It may work, it may not work. Give it your best shot, but note that whenever you create that new game, that code has never existed before, right? So then you're actually innovating something really new that's never been seen before. Definitely try to figure out how to put the paywall on and charge people, right? That will be very, very, very interesting. So Yusuf, once you figure that out, that will be interesting to share. Okay, so the neural networks, we go back to this. The perceptron is the building blocks for neural network. And the way it works is X1 and X2 are data, and the data is hitting the W1, that's a parameter. And the X1 times W1, you're going to do a plus, a summation operator. And this summation operator combines data plus the weights plus other data, X2, plus the weights, W2. Now, the data, X1 and X2, doesn't change. What does change is the weights. So think of the weights as knobs. And as you're making mistakes that we'll talk about later, when you make a mistake, you're going to take that error and bring it back through and actually adjust the knobs. And the knobs are W1 and W2. Those are the parameters. So the output is a function of the weights, which is what you're going to change. Those things can change. The inputs is the data, it doesn't change. And then something called the bias is just adding a constant term to whatever you have in the summation operator, x1 times W1 plus x2 times W2 plus B, which is the intercept or the bias. In machine learning, they call it the bias term, okay? And then you're going to sum all those together, and you get a scalar value, and you're going to put that through an activation function. Here, the activation function is a step, but you'll see there's many different other activation functions. Some of them are like the sigmoid, which is squashing function. Yeah, go ahead. You guys have to sort of talk if you're going to interrupt. Please, feel free. Okay, so this is the perceptron equation. F is a function, which is activation function, of the summation of Wi times xi, that quantity plus B. B is the bias term. Xi, Wi, these are input and then the weight, input data and the weight, and B is a bias function. F is sigmoid. Now, in this example, the input is x1 and x2. So look at the first row. X1 is 0, x2 is 0. There are 4 observations here. First is 0, 0, then 0, 1, then 1, 1. 1, 0, and then 1, 1. So look at the first observation, which is x1 is 0, x2 is 0. Weight W1 is 1, and W2 is 1. So what's 0 times 1? 0 times 1 is what?
Zip.
Good. Plus 0 times 1 again is what?
0.
Minus the bias term. Here, the bias term is minus 1.5. So basically, you have 0 minus 1.5 is what? Minus 1.5, right? Now we take that minus 1.5 and we put it through the activation function, max 0, comma, minus 1.5. What is the max of 0, comma, and then minus 1.5? What's the max?
0.
That's correct. So anytime that this is, what we did is one example, okay, and we put it through the activation function and the output is going to be 0. Whenever this is negative, the max of 0, comma, and a negative number is always going to be 0. And at the very end, we have the last observation. There's 4 observations here. 1, x1 is 1, x2 is 1, 1 times 1 is 1, plus 1 times 1 is 1. So 2 minus 1.5. Now you have 0.5. This is a positive number. So when you take the max of 0 and 0.5, you get 0.5, right? So that's an example of how a perceptron works. We just worked through one simple example so that you can understand sort of how the math works. All we had to do was multiply. We had to add, and then we have to get, add the bias, take that scalar, and then put it through some kind of activation function. Notice that when you put it through an activation function, you put a scalar in, meaning that you put just one number in and you receive one number out, okay? So the $1 million question is, which learns? Do the blue guys learn or do the green guys learn? What's the answer? You only have 2 choices. Either the blue. Blue is the data. Green is the parameters. Which guys learn?
Green.
Blue or green?
Green.
Are you sure?
Green.
How do you know?
Because you can change the parameters.
That's right. The only thing that learns, the data going in never learns. It doesn't change, okay? You put pictures of cats in, you put pictures of dogs in. You don't change those pictures, right? Here you're putting zeros in, you're putting 0, 1, 1, 0, 1, 1. You don't change that data. The data that's going in never changes. It never learns. It's just feeding the model, okay? The only thing that you're learning are the parameters. These are the weights. These are the green guys. You're twisting the weights. You're twisting the bias term. You're trying to fit this, whatever this data set is, okay? So the perceptron is built on data coming in. It goes through. There's some summations. There's some additions. There's some activation functions. It spits something out. And the only way that you can adjust the perceptron is adjusting the weights, okay? I'm not telling you how to adjust the weights yet because that's backprop, and I'm just telling you the distinction, first of all, is data goes in. It doesn't learn. It doesn't change. The only thing that are changing are these parameters, W1, W2, and bias. When you download one of those large language models, what are you downloading?
Data.
When you download a model, a large language model, onto your personal computer, are you downloading all the data on the internet that it was trained on? All the blue guys?
No.
What are you downloading?
The weights.
That's right. You're
Bias.
downloading the weights and the bias. You're downloading the green guys. The green guys have been 100 billion parameters, right? They're all the green guys. That's what you're downloading. You're using all those green guys. Imagine W1, W2, that green bias. You're downloading that, okay? Those weights and that bias has captured the relationship of all that data on the internet that's ever been produced, and any book that has ever been produced that's been pushed through this model. All those weights have been optimized. When you download a model, you're downloading the parameters. You're downloading all the green stuff, and now you're just using that, okay? It's very important to understand the distinction. So when we say, hey, let's go use a model, let's go use a pre-trained model, you're basically taking all the green guys and saying, okay, give it to me, right? When there's an open source large language model, it says, go ahead, use this model, you're basically using all those green guys, the weights, the green guys. They're showing you all that. You can download it. A model is just a bunch of weights and biases. It's just a bunch of parameters. That's all it is, okay? Now, some models have trillion parameters. Some of them have 100 billion. Some of them have 60 billion. Some of them have 100 millions, right? But remember, a model is just a bunch of weights. That's all it is. It's a bunch of green guys when you download, okay? Now, I haven't told you, how do we get the green guys in the optimal position, right? We haven't discussed that at all. But I want you to first understand that large language models are basically a big matrix of the green guys. That's all it is. Nothing more than that. Each of those green guys have been fine-tuned based on all the data on the internet that has been, quote, pre-trained, and it takes hundreds of millions of dollars to do that, but nonetheless, you're basically downloading parameters. That's what a model is, okay? Right, very good. We looked at the perceptron, which is the one on the left. If you look at that neural network on the right-hand side, and you look at the first three, the red guys are the input, those nodes. Those red three nodes, they're all pointing to the top hidden node at the very top. There's three arrows pointing to it, right? That is a perceptron. Now the hidden node, the second one is another perceptron. So all three of that input data, right, that is coming in on the left-hand side, which is the red guys, all three data points are going into each one of those nodes. When it goes into the first node, that's a perceptron. When it goes in the second node underneath that in the hidden layer, that's another perceptron. When it goes in the third one, that's another perceptron. When it goes in the fourth one, that's another perceptron. You have literally stacked perceptrons on top of each other, okay? Now, from the hidden layer to the output, there's two outputs. Let's just look at the very top one. Now, the output of that hidden node, again, is like a perceptron. The data goes through those arrows. And now you have a perceptron with 4 inputs, because you're basically, there's 4 inputs coming out of each one of those hidden layers. There's 4 nodes in the hidden layer. And now they're all going to the top node in the output layer. That is another perceptron. So a neural network is just a bunch of stacked perceptrons. Perceptrons have weights and they have data, and also a bias term. The data that goes in, x1, x2, doesn't change. The weights change. Those are the green guys. The weights capture the relationship, and we have to sort of tune these weights. And we'll learn about how to tune these weights later, but it's enough to know that when you download an LLM, which is this huge neural network that has a bunch of perceptrons stacked on each other, you're downloading the weights, okay? And those weights have been predetermined, pre-trained by all that data on the internet for a large language model. So basically, you're just taking all the weights, all the parameters, which is pretty cool, all right? Now, we'll learn a little bit more. Here are some examples of activation functions, also known as squashing functions. they take one single input, which is a scalar input, a number, and then it outputs into another number. Sigmoid is the one that's at the top left-hand corner. That's very popular. Also, Liew. Leaky, R-E-L-U. R-E-L-U stands for rectified linear unit. Okay, the one that we did just now was ReLU at the very bottom, nax of 0, x. Okay, some of these activation functions are bounded, meaning that the y value is stuck between 1 and 0 or 1 and -1. And some of them are unbounded, like ReLU, it goes from 0, but then it goes to sort of infinity. It's going up one by one, right? And ELU looks a little bit like a leaky ReLU, but it's smoothed at that corner position. So there's a derivative. You can take a derivative anywhere along that, okay? So these are different types of activation functions. This brings nonlinearity into the neural network, which is nice, right? So that's, we'll get more intuition and build, work with them later on. So the building blocks for a neural network are multiplying weights in the data, the summation operator, and then adding a bias term, right? And then bringing it through one of these activation functions. And you can have a different activation function for every single node in the hidden layer or whatever you want. Most people will use something like a leaky ReLU because that's works pretty well. They initially started out with using a lot of sigmoids, right? Because you can take the derivative of that activation function all over the place. But here's an example where you're just getting some exposure, building a little bit of intuition, and now you're seeing a couple of activation functions. Okay. All right. Part of your homework assignment. There's 3 parts to your homework assignment. The first part is actually watching this 3 blue, 1 brown YouTube videos, okay? There's 4 of them. You gotta watch all 4. The first, second, third, you're probably gonna be pretty, like the first one you'll be able to understand. The second one, you'll start to build some intuition on gradient descent. Backwardation is the third one where you're moving how do you move the parameters to adjust so that it fits this sort of space. The fourth one is difficult unless your math skills are pretty strong. So don't worry, just watch it and just get a sense. That might be a little bit much because it uses a lot of indices, subscripts, and superscripts, but also tries to do it in matrix notation, and it's a little bit difficult. So don't, just watch it, just get exposed to it, and I don't expect you to understand all of it. Some people who are pretty strong in matrix multiplication and so forth can kind of understand that, but just watch. I believe like the first, second, and third, you should build some intuition. The fourth one, just note that it's going to be mathematically a little bit difficult for those who are rusty in their math, which is probably most of you guys. Most people who work in the industry, because they're not doing calculus every day, they get rusty in linear algebra stuff, which is fine. So perceptrons are the building blocks. We got to really understand perceptrons. Neural networks are just stacked perceptrons. And then understanding that backwardation, after you watch the videos, you'll build a little more intuition on backwardation. We'll do a couple more exercises next class. And backwardation is where you're getting the data through and you're training and updating the weights. You're updating the green guys. You're updating the knobs, okay? You're sort of, tweaking them to fit the data to some end. We haven't discussed that yet, right? Okay, and then let's see. You guys, Google Notebook, definitely put some PDFs in there. Now you know Windsurf, so those are the 2 tools that you're going to sort of learn this week. Some people already have done it. Inside your module 1, there's going to be this McKinsey State of AI. This is basically interviewing a bunch of CEOs, and they talk about how they're using AI in their organization. Interesting enough, CEOs, the top organizations, know and use AI more often than mid-level managers. So that's keep that in mind. And then you're going to basically Google search Google Notebook LM. You're going to dump this PDF in. It's going to create a really fast summary. It's going to look like that in the middle, and then on the right-hand side, it's going to be this podcast, and you're going to hit this button. I think it's over here. It's going to create a podcast. You're going to listen to the podcast, and you're going to comment on After you read this, read the summary, and then the podcast, you're going to say, hey, is this a very good podcast? Yes or no? Does this help my understanding? Yes or no? Then you're tasked to put in any PDF, which is 20 pages or less, or some kind of YouTube video on a subject matter that you're not familiar with, and it's going to create a summary, and you're going to also listen to the podcast, and you're going to say, hey, does this help my understanding of whatever is in this document, right? So that's part of your homework assignment. All right, let's see what's next. You guys have started doing some vibe coding, and hopefully you guys enjoyed the vibe coding, right? With the #1 programming language, which is English. Thank you very much. Skip that. Oh yeah, here's the one that's fun. Now, the real world example of a problem is that you join an organization and you have a lot of data. Unfortunately, you have no data scientists and you don't have any budget because data scientists are expensive. So what are you going to do? Well, first of all, you need data. So we're going to use publicly available data at the UCI website, University of California, Irvine. It's all publicly available data. This is what people use to, train models. Don't worry. It's public, it's fine. It's all for, you can digest as much as you want here. Usually it's some kind of old data set, right? The one that's very famous is the one from Iris. This is the Iris data set, it's the first one. This is the very famous one. Now here's my prompt. I'm using Windsurf. I say, you are a seasoned data scientist. I have personified the LLM as my data scientist. Remember, I can't afford a data scientist. You are given this data set available here. I put the actual URL to the location of the data set. Now I'm telling it what to do. Download the data and put it into a ./data. That's a folder, okay? So it's going to download that data in the folder. Now it's local. I can use it, as much as I want. And then proceed to do a visual analysis of the data. Data scientists, they have to know what data they're looking at. They have to sort of look at it, use all the advanced graphing techniques and make an interactive web page to show off your results. Use best UX UI. Now, the data scientist has a new skill. They're the human-centered designer, and they have to know user experience, user interface, and best human-centered design principles. Make it easy to use. That's the first step. Call the project UCI_Iris. So I did that, vibe coded that, and I get something that looks like this. Okay, I can't zoom in here. You guys will have the notes, but basically there are a lot of really interesting things that are here. I want you to try to create something similar, right? Now, if you get stuck, just use the Iris data set and use sort of this prompt. However, the homework assignment is asking you to use a different data set. Don't use anything big, meaning don't use anything with, 50,000 or even thousands of lines of data. Just, use something small, hundreds is fine. And, pick a data set that maybe you're not familiar with and see what you can do with that. Basically personifying a data scientist, creating an app so that you can look at the data, understand the data, and, that's part of the homework assignment. Okay. So this is your assignment for this week. I know some of you guys already got started on it. So number 1 is you're going to review the videos on 3 Blue, 1 Brown. This is probably arguably the best way to understand some of these neural network concepts. They explain it really, really well. The data set they're going to use is MNIST, and we'll have more exposure to that next week. But now you're getting a sense of what this is. Watch those 3 videos. The last video is going to be difficult, so don't kill yourself. Just watch it. It's going to be fine. You're going to write a half-page summary explaining neural networks and backpropagation in your own words. Yes, you can probably use Google LM to do it, but I want to hear your own words. I want you to write it down because it helps you remember. It helps me know that you did something, and when the class is over, you'll still retain some of this knowledge because you actually regurgitated it to yourself, and these are your own words. Number 2, you're going to use Google LM to summarize a podcast. You're going to summarize the state of AI. You're going to read it and then summarize it. It's not a long article or report. And then you're going to pick something else, like some subject that you've never, ever really, you have very little prior knowledge. And you're going to, dump it in, look at the summary, do a podcast, and then you're going to ask yourself, did this improve your understanding? the other question is, will you ever be afraid of any new topic now with Google LM? So now you have a tool to summarize and understand, big picture stuff. Now it's not perfect and it could hallucinate. You could comment on that. However, there shouldn't be any topics that are scary to you with these tools. Google LM does a lot more. You can do questions and answers, frequently asked questions. You can interact with the data, and I'll let you sort of play around with that and figure that out. The final assignment, the final task that you have to do is vibe coding. Try not to spend more than $20. I don't think you need more than $20 for any of the assignments. Most of you guys have created the snake game. Now you're going to create another game, and then you're going to basically combine these two games. Combining the two games is probably something that's never seen in the world, and you probably put a payroll and charge people a quarter or whatever to play your game. So that's going to be interesting because then you're getting the LLM to create something creative that's never been seen before. People have seen the snake game before. The code's out there. It's publicly available. Choose a game that's simple, that the code is out there, but crossing those two things or combining those two things hasn't been done before. So you'll be on the cutting edge of that. The other part is go to the UCI website that's available here. Pick a small data set, create the visualization. You can use the prompt that I'm having there, download it, visualize the data. You can create prediction models. You can ask it to create, what is the narrative of this? How can I use this? What kind of ROI can I get out of this data set? And so forth. All your vibe coding assignments will be done in a 3-minute video. You're going to narrate your journey. You're going to tell us what data, what is your first game, Snake? What is your second game? Here's an example. When you crossed it, what happens? Sometimes it'll work, sometimes it won't work. If you get stuck, you just say, what did you try to do? Try to get unstuck. Okay. Sometimes you'll be able to get unstuck. Maybe you won't be able to, and then that'll be it. Hey, I tried it and it didn't work. You couldn't figure this out. But if you cross the snake game with something else, then you have created something really new and interesting. And now you're tapping into the creativity of the LLM and the real superpowers of it. In my opinion, Elon has some earnings conference call, and he said this is a glimmer of the LLM becoming creative, because now you're creating something that's never existed before. Then you'll also do the narration of your data science project as a data scientist. And now I want you to share your 3-minute video that you narrated. You have to talk about it. What are you doing? You can't just create a video and not say anything. You have to tell us what's going on, right? This is my video that does X, Y, Z. Here's what the data set I looked at. And these are the things I think are interesting, right? Share it with your class, spend time, make a nice video, 3 minutes max, no more than 3 minutes. And then you're going to post it up into discussion boards, share with classmates under discussion assignment 1. We're going to share our vibe coding videos with each other. And you can only say positive things about other people's videos. So only thumbs up. If you like it, share comments, no negative comments. Everything has to be positive. Okay. And then finally, on the last page here, here are some resources. Next week, I'm not going to be here because I'm going to go to New York and go to some AI agent. I want to see Andrew Ng sort of talk about what's going on and hopefully bring that in the classroom to share. But I will make a video on Thursday so you can see what that is. We're going to cover more about neural networks in depth, and then we'll have a couple of, some more things to do. Each week we'll have an assignment. So that's basically how the class is going to go. So next week, there will be a video recording that I'll make probably on Thursday. All right.
Thank you, Professor.